start recording. Okay, today I would like to do a little bit more of an educational, hopefully educational video about register allocation in the presence of register pairing. If you don't know what register pairing is a technique to represent a higher bit width than the native machine word. So if you want to represent 64-bit value on a 32-bit system, then what you usually do is you take two pairs, for example EIX and EDX on Intel x86. You would take those, you treat one of them as the high word and the other one as the low word. I think by convention you pass the 64-bit values as the register pair EIX, EDX in the System 5 calling conventions for 64-bit integers, and yeah, that's basically pairing. So when you do register allocation, that essentially means associating a memory location with a register, right? Usually you put your local variables and such on the stack. But what you can do is you can say, if I have 3 registers and this local is accessed often, then let me associate, at least for a certain time frame, a register with this variable, and whenever I'm asked to operate on that variable, I can simply operate on a register because I know that this variable has been stored in a register. In C, there used to be the register keyword for this, to tell the compiler this variable should really just alias a register. Did I type associating right? Wow, gets even worse. There must be a better word than associating. I could say pairing a memory location with a register, but then we would get issues with the register pairing. Assigning a memory location to a register. That's also not quite the same thing. Let's say aliasing a memory location with a register, or to a register. I guess that also works. Okay. Anyways, so when I have an index in a function, let's say int void int f int b, then I have int x equals 4, and I do return x, or return v plus x, return v plus x. So there is an optimal way to work with this on x86. So what you have to know is, by default on the x86 calling convention, values that fit in a register, if you return a value that fits in a register, it gets returned in EAX by convention. So what I could do here is I could say this variable x will now be stored in EAX. So instead of that, I say move v into EAX, and then you add x to EAX, and you return. And node, no, there. That would implement this function. You just have two instructions. And add EAX v, right? So if we say x is EAX, then saying x equals 4 is the same as saying EAX equals 4. So we move 4 immediate into there. I think $sign is for immediate. No, hash sign is for immediate. We move an immediate 4 into there. We add wherever v is into EAX, and I believe, according to the system v calling convention, the first parameter is stored in some register, let's say EDI, is that correct? I think it's EDI. So if v were EDI, let's just say it is, v gets stored in EDI, then we would just have an add on those registers and we would be done. So that's that. And register allocation is basically making sure that this alias relationship between a memory location and a register can exist for the longest amount of time, because storing things from the register back into the memory location that they came from is a bit tricky. So for example, what we could do, let's take an example from D. If I have a thing like set 0 output parameter of the thing I want to set to 0, then in this case I would say x equals 0 and it would return. And what that would do is it would move a 0 into the pointer that x represents. Right? Because that would be passed as a reference to a variable. You could also say that. And then we basically deref x and we would move a 0 into there. And yeah, that you would usually do by having a register move. So what you can then do is, if you have a free register, you say you XOR, let's say EAX, and XORing a register with itself puts it to 0, and then you do move. Let's say this also gets into EDI. Then you do move EDI indirected EAX. And in this example, if your calling convention mandates having to pass by registers, then the only thing where you would need register allocation is here to check if EAX is free. Not sure if that's so understandable.